say, two technologies existing already for many years in our business. So the floor is open for questions to the speakers. May I invite you to raise question, please? We have another 10 to 20 minutes for it. You, sir, you have a question too? Yeah? Come forward, mention your name, your organization.
So my name is Masaki Sasaki, staff writer of a Japanese newspaper. So Netherlands has a sophisticated technique against flood and water. So now I understand that water business is getting bigger and bigger. But a Netherlands company has many rivals in all over the world. So please tell me about this market and chance winning against many rivals. And the second question is, please, I would like to tell me about support of government of Netherlands.
Okay, Jan-Peter, shall we do it together? Because about why is the Dutch, why are the Dutch so innovative on water treatment technology? That is, we have found a system or a way of collaboration. There is need at the water companies and the wastewater companies. And there is a big tendency to do more with less. So less energy, less chemicals, etc., etc. You are now in Amsterdam and you drink water from the tap, and this water is not chlorinated. You will not find any chlorine in our water. And we achieve this because there is an intensive collaboration between science, the public companies, the water companies, and the private companies. Have you add something to it, Jan-Peter? And this is a natural environment for us. We do it together.
And in addition, we strive to high quality, and we have to deal with environmental pollution. So research institutes, technology suppliers, and end users are working together to find the best solutions economically and with respect to quality. That's the driver, I think, for the innovations here.
And can you repeat your second question? What was your second question?
So how about the support of government?
Yes, yes. We find that our government is always doing too little to support us. I've seen, next week I'm in Korea at the InKim conference, and we see around us lots of support of governments, even in the United States, to support this high-tech breakthrough technology, etc., etc. We have addressed water and water technology as one of the top sectors for the Dutch to become leaders worldwide in the market, in the world market. And our government is giving subsidies. They are not big, at a maximum 30–35%. The private and public sector have to do it themselves. We have a technological top institute up in the Netherlands. It's totally addressed and focused on water technology, membrane bioreactors, membranes, etc., etc. But the real thing is that we collaborate a lot. You have seen in the presentations that companies are working together to bring something new to the market. And I think when we have coffee break, I can tell you more.
Okay.
More questions, please. How are you? See you next week.
Hi, I'm SK Hong from Korea University. I'm glad to see Lute here. I have a question to Mr. Timmer, who made the first presentations. And I'm just wondering what kind of membrane that you use for your system. And is a normal outer membrane module, like a spiral wound modules? Or you have a specially designed membrane module for your systems?
Harry, can you come here?
I'm afraid I have to disappoint you about the details of the membrane, but the what we aim for is to use normal, conventional, industrial available membranes for this this concept, because we like it to not to be exclusive in the end. It should be well, not too expensive in the end. So we don't do funny detailed tricks on the membrane itself. The concept is innovative, but we use standard membranes.
Okay, maybe I can ask you a question. Already any idea about the cost and the energy consumption?
We think it will be about 60% of a conventional system operating with the same recovery.
OPEX plus CAPEX, so running cost. 60% off.
No, only energy cost, but we
Energy cost,
we
okay.
think that energy cost will be one of the largest costs of the system.
Okay. Any more questions to Harry about his lecture? Robert?
I had a question. I thought it was an interesting concept, by the way. I think that's a great thing. Is this applicable? I noticed that in various situations here, you have salt water and you have fresh water at an angle based on the difference in density. Is there any application for directional drilling to instead of having vertical wells, to have horizontal wells or wells at an angle that take advantage of that difference between salt water and fresh water?
I think this concept, when it's proven in a vertical direction, and then we can elaborate on it and say, perhaps we can do a horizontal drilled well, and then try it again.
So. Yeah, no, I mean you gotta prove it out first, vertically, but it struck me that it might also work for horizontal wells, and in some cases I think horizontal wells are often under-recognized because they're less sensitive to the groundwater, the brackish water down below. But it seemed like your concept would work either way, and it could be very interesting. So.
Okay, thank you.
Thank you.
Any more questions to Harry? I have a question to Maxime. Maxime, we are both familiar with membrane bioreactors in side stream using air scoring by bubbles instead of submerged membranes, which seems to be the standard, but from membrane perspective of you, I think it is the wrong thing. You compared upstream and downstream. You gave me the idea that downstream is better, lower energy and so on. Why is that? What is the difference between a bubble going down and a bubble going up?
It has to do with the optimal repartition in that case. When you go up, if you have more bubble in one tube, it will go faster because the air wants to go up. And then you will have at one point most of your bubbles going through a few tubes while the rest is just going with water. In the case of going down, it's the other way around. If in one tube you have no air, then the bubbles will go towards this tube. So that's the main advantage, this repartition of the air. And that is quite easy to see with the pilot of the you really can see that the air is really well reparted. Within a few, when you have this in plexiglass, within a few centimeters, every single tube gets the same amount of bubbles, thanks to the static pressure of the water.
Thank you. Any more questions to Maxime on the membrane bioreactor? No? So you expect big sales? Yeah. Okay. Then is there any question to Robert on the nano composite seawater reverse osmosis? You, Jan-Peter.
I very like the concept with well, more water or less energy, so I think less operational cost. But can you tell something about the capital cost? Is it much more expensive to create such a membrane?
Yeah, so in terms of the capital cost, it really adds much less than 5% to the cost of a membrane module, because when you think about it, most of the cost is in the packaging, if you will. Okay, you've got the outer shell, you've got the 3 different layers. That's where all of your cost is, and so from the point of view of adding the nanomaterials, it really is not significant. Now, I have to tell you that if you're saving that much energy or you're producing more water, a company wants to get a premium for its membranes. So I can't tell you that there isn't some premium involved. But basically, in terms of actual material cost, it's pretty insignificant to the overall. Thank you.
I have a question to you, Robert. Can you tell us a bit more about the mechanism? What do the nanoparticles do? Or you don't like to tell us because you are revealing secrets?
I think that's where a private. All right, thank you. I'm afraid that's where a private company comes in, and having many years ago an academic background, I would love to talk more about that. But suffice it to say that the polymer structure is being changed, but the basic way that membranes operate, and there's even still some debate after these many years about how they operate, but I think a lot of people accept this sort of solution diffusion mechanism. That really isn't altered, except there is a difference in the polymer structure that allows more water to go through. The original concept, when this sort of the very early concepts came from Professor Eric Hook at UCLA, and he argued that there was actually some transport of water through the nanoparticles themselves, and we don't actually agree with that. There may be some, but we actually think that it's the polymer structure that's changed, and that's really what's happening. And you do the calculations, and it's pretty hard to say that the amount of nanoparticles that we put in can make that much change. So. That's about all I can tell you.
Okay, but it has nothing to do with the mechanisms of aquaporins.
No, it is not, and I think that the aquaporin methods and the stuff that especially that's been developed here, I think it's very interesting. It's not. I haven't seen that it was quite commercial yet in terms of. Getting, making rolls of membrane, but I do think that's an interesting concept. But these are not aquaporins.
I'm an investor also, and they are asking me to invest in aquaporins. May I have an opinion from you? How far is this from the market, or should I invest in nano H2O?
I think that's an easy question for me to answer.
Yeah. but give the audience an opinion, because you are all working in the same direction, and make it cheaper and cheaper.
I think that there is there's a whole group of technologies out there, some of which require. I sort of divide them into two pieces. There's those that require new infrastructure, such as forward osmosis. You have to have a new machine, okay, and those that can really pivot off of the existing infrastructure. So aquaporins conceptually can work under much the same infrastructure as we already have, and I think that's a positive. I think what is more difficult for aquaporins is just that commercial production of those, and I've kind of put them into a category that in my mind it's competition, but it's competition that's maybe 8 to 10 years away, and so it depends on your the viewpoint that you have. I mean, I look at carbon nanotubes, for instance, and they got a lot of play in Science magazine and various places. But when I did dive down into the research there, and again, I'm like, wow, that's 8 or 10 years off, if ever. There's some good concepts there, but it's still a ways to go. And I think it's probably a better question for the people that actually work on aquaporins, because they may have a very different opinion. I'm coming at this from the outside. I mean, what I know are nanocomposite membranes.
Thank you. Another remark maybe. Can you give us a scenario where nano H2O is going to? Is it this? Is it it? Or can we expect more from you?
No, I think you can definitely expect more. We're looking at I mean, each product, we don't want to have a product which is a Me Too product, the same product. So we have some lower, I mentioned some of the lower flux membranes, but they've got higher rejection, okay, than what else is out there on the market. Higher flux, and so we want to go into brackish water, which I think is of interest, especially to this group. And I've got some brackish water membranes that are in research and development now, and I'm trying to look at that with respect to higher flux, in other words, lower energy. But there are some applications for brackish water where you want higher rejection. So I'm looking at that and looking at where I can get that balance. So we're looking at brackish water membranes. We're looking at water reuse membranes. But again, I have to look at how can I discriminate myself from what's already out there. There's some very good membranes on the market, and I don't want to say that they're not. There certainly are, and so how do I discriminate myself? I think in the water reuse market, we've got 5 different methods that we're looking at in terms of controlling fouling. And I think both organic fouling, inorganic fouling, depending on how you want to define it. So again, I think that's where we have to innovate. And for us, it's keeping that R&D group focused and putting out new stuff and not getting too involved with product development directly. It's just keeping that research focus, which we're trying to do.
Thank you.
Thank you very much.
Any other questions? I have a question to Harry about that combination of ecology and technology. We have in the west part of this country a lot of greenhouses. They do a lot of reverse osmosis. What do they do with the brine?
Well, I'll answer it here. That's an interesting topic. At this moment, there are about, I think, 600 greenhouses operating a membrane filtration unit, and they put away the brine into the aquifers that we, use
into
for
the
drinking
aquifer.
water production. So that's where the environmental laws come in, because we're not in favor of this this enormous amount of operation of small RO units into the western part of Holland. So if we do this technique, it should be carefully monitored, it should be carefully designed, it should be on a large scale, well performed, and I say let's do it with the water supply company.
Thank you. Is there any other question from the participants? If not, then I come to the closing, and it's my task to, in 5 sentences, to summarize. I think the first lecture was a very nice example of technology plus ecology addressing a problem of saltwater intrusion. Then Maxime talked about membrane bioreactor and brought again to the market an improvement, doing less, more with less. So more output per membrane area with less energy. Then the nice lecture of nano H2O, which gives complete new membranes to the market, but also gives us the option of do new plant design. I think that's a very nice example where you combine the properties of the membrane with the plant design. And later, a nice example of hybridization of 2 existing technologies, pellet softening plus RO, and I think they all gave nice examples of, say, innovation in our world, which means we have to address the world water problems in doing more with less. I thank you very much, and the speakers and the participants for being here.
Okay, Lute, thanks for sharing this session. We will now have a coffee break till about 11:20.